In this video, we're going to figure out how to look at a column of data and then organize it into bins that could be used to construct a histogram. Essentially, we're going to take a collection of data and then divide it up into different bin sizes and count how many of the instances of the data fit to each bin, a process that we call binning. So what I have up here is Excel. We're going to look at the data in just a moment, but first we have an outline of the process. It's going to happen in about 5 steps. The first is to determine the number of bins. The second is to determine how large each one of these bins should be. The third then is to find the upper edge and the middle position of each of these bins, and then to count up the number of items that are in each one of these bins. And we're going to use a lot of formulas in Excel to do that. And then finally, we would export this as a CSV if we wanted to put this into views or something like that. So we're going to start here with the first step first, and there'll be 3 sub-steps to this. First, we're going to figure out how many items there are. Then we're going to take the square root of the number of total items to give us an estimate of how many bins we might want to use. There are many different algorithms and formulas that people use in order to determine the number of bins. We're going to use a simple one here, which is simply to take the square root of the number of items, and we'll discuss in more detail later on in the semester what the other options are. And then that won't give us a round number most likely, and so we'll just pick an integer value that we think will be easy and convenient to work with. So let's have a look at the data and get started. The data are present in the other sheet here, so I'm going to click on that. And what I have is the average rate of return of a stock market when it's averaged over periods of 5 years. And that column is shown here in column A. You can see if I take here and scroll down, there's a number of entries, and in fact I can see that there are 87 rows. The top row of this is a title, and so that must mean we have 86 values. This one's pretty easy. We can look at it and see that, but I also want to use a formula to count the number of items, because there might be times where it'll be faster and easier, especially when we have a large number of items, to figure this out. So I'll use a formula in Excel, and what we want to find, I'll label it first, is the total number of items. I'll double click up here to resize this cell, and then to get the total number of items, I'll use a formula. To start a formula, you press the equal key, and then I will say count. That's the command. You'll see that it brought up a menu, and it'll tell me what this does. Count counts the number of cells in a range. I can start telling it how to use this command by opening a parenthetical statement, or using a left parentheses. I see that the count is going to return value 1. And what I really want to do is give it a range. I want to count row A, or column A, and all of it. So I'm going to type A, column A, or colon A colon A. That selects all of row A. And importantly, count only returns the number of cells that have numbers. And so it should say 86 when I hit return, which is what we see. That's the end of the first part of this step. The second one is to figure out how many bins we need to have, and I said this would just be the square root of the total number of items. So we say number of bins equals, okay, I'm again using a formula, the square root formula. Oops. What I need to do is square root, and then I can select the cell I want to take the square root of. That's going to be 86. And what you see is that I end up with 9.27. So I'm actually going to set the number of bins equal to 9. That'll be fine. It doesn't have to be exactly what we calculated. In fact, it has to be an integer. So we'll just round down and use the number of 9. The next thing we need to do then is move on to step 2. If I go to our plan of attack, we see that we've already rounded out a good number for the number of bins. We have an integer we want to use, which is 9. So let's move on to step 2. What I'm going to do here is find the maximum value, so the largest value that we'd have to experience, the smallest value that we're going to have to account for, and then use that to calculate the full range of values that are spanned by our data. Once I have the range, that's the total spread that we would like to divide up amongst our 9 bins. So I'll take that entire range of data and divide by 9, and that will give me the size of each bin that I want to use. Let's head back to the data. I'm just going to keep under row C giving titles of things I'm trying to find. So I want to find the max value. There's a simple formula for this as well, or function. And so I press equal to start this formula. I say find the max, which I just use max, parentheses, A colon A, parentheses. Now I'm going to find the maximum value in column A. You can see that the maximum, the largest value we're going to encounter is 0.284. I'll do the same for the min value, the minimum value that we would expect. You might be able to guess that this is just going to be equals min, parentheses, A colon A. And hit return. We'll see that the minimum value is negative, so there was a time where there was a negative return from the stock market here. And then to find the range of values, I'm simply going to set this equal to the max value. So D3 minus the min value, hit enter, and now I have the total range of values that I need to divide up into the 9 bins. So to get the bin width, I'm just simply going to make a formula where I take the range of values that I need the 9 bins to span and divide it by the 9 bins. And now what I have is that each bin should have a size of about 0.041 or so. We'll use this exact number when we divide up our data. But this is how we have the bin width that we need. So now we can move on to the next step. Here we're going to find the upper edge in the middle of the bins. We need each of these. The upper edge helps us count what we're interested in. The middle of the bins tell us where we're going to eventually put the error bars. Now, there are many ways to bin up the data from this point forward. I'm going to give you one that I think makes sense to me and is easiest to type out formulas for, but if you're comfortable with Excel, you could probably come up with a faster way to do this. Again, I'm just showing you the way I like that is going to involve the simplest formulas to type out. Okay, so what we need to do is find the upper edge of the bin and the middle of the bins. Let's go ahead and do that. We'll go back to the data. I'll start a new column where I write down bin number. I want to know the upper edge in the middle of the bin for bin 1, 2, 3, 4, 5, 6, 7, 8, and 9. And what I'm trying to find is the bin upper edge and the bin middle. Great. So let's do the upper edge first. We'll make this large enough that we can read everything. In order to find the upper edge, essentially, if we think about where bin 1 is, it's going to start at our minimum value, what we see here in cell D4, and then it's going to go upwards in value by 1 bin width, and then it's going to hit the upper edge of its bin at that point. So to find the upper edge of bin 1, I simply set this equal to the minimum value plus the bin width. That gives me the upper edge for this bin. Now, when I go to bin 2, what happens is I look at the upper edge of the first bin and I just add the bin width to it. So this formula is slightly different. It's going to be H1 plus the bin width, right? I'm just moving 1 bin width higher up. The same thing will happen for the third bin, and so I can just copy the formula I just made. This formula said, if I click on it, you'll see that I took H2 and I added the bin width to it. Now, before I copy this, I want to make one change to the formula, which is to put a $sign in front of the 6. This $sign is going to indicate that the 6 should not change when I copy and paste. Now, if I copy what I have in cell 2 and paste it into cell 3, what I find is that I have a new formula, where I take the value in H3, the cell right above this, and I add to it the bin width. And I can do that for the rest of these values. A simple shortcut is to select the cell that you want to propagate down and go to this little square in the bottom right and double click on it, and it will just move everything down. So now we see for every one of these formulas, like the last one, if I highlight it, I take the cell above it and I add to it the bin width. This gives me the upper edges for all the bins. I'd also like to know where the bin middle is. That's going to be nice when we start looking to plot our data. And what you could imagine is that the bin middle is going to be 1/2 width to the left of the upper edge, right? Another way to think about that is the bin middle is the average of the lower edge and the upper edge. You can think about it both ways. I'm just going to basically say I want to take the upper edge I just found, right, the right-hand side of the bin, and subtract 1/2 a bin width. The reason I'm going to do this is it's just easier to type out the formula, so I'm going to take the upper edge of the bin width, and I'm going to subtract 0.5, that's 1/2, times the bin width. You'll notice that the bin middle is more negative than the upper edge, as it should be, and it should be halfway in between the minimum on the left and the maximum on the right for that bin. And I can propagate this all the way down. Okay, at this point we have locations for the bins of interest, the upper edge and the middle, and what we can do is start counting. All right, that's what we really want to do. We want to count the number of instances in the data over an A that fit into each one of these bins 1 through 9. We're going to do this in a few steps. All right. At this point, basically, in our plan of attack, we're down to step 4. Count the number of items in each bin. And we're going to do this in 2 stages. So actually, let me just add that in and type it out for us. Adding in these 2 steps, essentially we're going to count everything that occurs below each bin upper edge. And then once we have that, to find the actual numbers in each bin, we'll subtract essentially n minus 1 from n. And you'll see how this works in just a moment. So back to the data, I want to say totals below bin upper edge. That's the first thing we want to find. To do this, it's pretty easy. We're going to count things back in row A, where our data is, but we're going to do a conditional count. The formula for this is equals count if. And you can see the description says we're going to count the number of cells in a range. And what you can't see because it's cut off is that it counts it when they meet a certain condition. So we're going to start this. You'll see what it wants you to do is to add a range and a criteria. Our range, we want to count the data in row A. So that's A, colon, A. Then I press comma to enter the criterion. If we want to perform a logical operation, like maybe we want to look for everything below the bin upper edge, we start with double quotations. We say we want things that are less than, so that's our logical operation. We insert an ampersand and then click on the cell whose value we want to check whether it's less than. And then I close out the parentheses, and what this formula now says is we're going to count everything in column A that's less than the value we see in H2. Everything that has a smaller value than the upper edge of this bin. If I hit return, you can see it counted 4. We'll do that for everything. So I double click to propagate this. What you can see is that the numbers continue to increase because we're always counting the total to the left. All right. Then what we have at the final part here is to count the number in each bin. And the thing to realize here is that there should be 4 in the first bin. The total went from 4 to 9, and so that means the gap between 4 and 9 is 5, or that there was 5 in the second bin. And so for the first one, it's pretty easy. We'll just set this equal to that bin. For the next and all the rest of the formulas, what we want to do is take the total that are below the upper edge and then subtract from that all the totals below it. And then if I propagate this, now I have something that's beginning to look like a Gaussian distribution. I have something with 4 in it, 5 in it, 10 in it, 11, 13, 9, 15, 4, 4. Okay, this looks pretty good at this point. And at this point, we're basically done, except there's one error, which some of you who are following along closely may have noticed, and that's that the total number of things we've counted is 85, but when we look at how many items there was really 86. The problem arises because we've made our bins just a little bit too good. The actual bin width is perfect, such that when we count, it ends at the absolute highest value we have. Okay? And so that means that when we're counting here, our COUNTIF formula, when it's below the bin edge, it's not going to count the one that is right at the bin edge. And maybe the easiest way to fix this is to change this logical operation from less than to less than or equal to. So we'll just add an equal sign in. When I hit return, now we're counting that value that's right on the bin edge, and we have 86 total counts, as we expected. At this point, we really are done. We have a table where we have the total number of counts in each bin. We know where those bins are located. And so if we had to, we could go into views, and you saw this in one of the other videos, or you will see it if you watch the video on making a histogram, where we can put these values as a bar chart centered at the location given by the bin middle. And that's how you bin up data for this particular set of data.